Welcome to Tetryonics and the formulation of quantum gravitation. In this lecture we'll continue on from the early parts of the Tetryonic Book 4, Cosmology, where we introduced definitions and geometric models of spatial coordinate systems, energy geometries, and clearly defined the difference between mass, energy, and matter as Tetryonic geometries. We'll then now continue on to explain the various formulations of gravitation and field interactions and develop a quantum theory of gravity that can be applied on the quantum as well as the cosmological scale, in turn replacing General Relativity and Newtonian Gravity in the process through a geometric process. First off, obviously having defined matter in the previous two lectures as the tetrahedral standing wave of energy and the black body or kinetic chem energy fields as the equilateral energy fields that surround them due to their motion or raised energy levels, we can now go on to deeper and deeper understandings of the interactions of electric and magnetic fields and the convergent force of gravity, in turn combining those two and giving us a quantum theory of gravitation. On the first page here, it's simply an introductory page to highlight the tetrahedral geometry of standing wave mass energy is what we call matter. The chem fields created through the motion of matter or black body radiation due to raised energy levels are all equilateral energy geometries. And Lorentz's formulas, which are the foundation for relativity, can in fact be redrawn simply as the measurements of the linear momentum, or in this case between velocity and the speed of light, and the scalar energy of the same field, in this case v squared, or the Compton frequency, per c squared, or per unit of time, per second. In the case of matter, you would have to change it from c squared to c to the fourth to measure the mass energy content of matter. The time energy or the energy densities, normally expressed in relativity as stress energy tensors, can now be revealed in their matter energy forms, and the forces between two material objects, two forms of matter, as illustrated there, can be shown to be the superpositioned energy momenta of the two fields, or the kinetic energy squared of the two fields. As separate objects of matter, they would have kinetic energy fields that are measured, whose mass energy is measured per c squared. When they superposition and interact, their fields are obviously c to the fourth kinetic energy squared, or the mass of the kinetic energy is determined by dividing the square of the kinetic energy by c to the fourth. Just so happens that measurements of matter, or the mass of matter, are done in c to the fourth as well. So by using the speed of light as a convenient basis for the geometry and the measurement of time, it can also be rationalized that superposition fields have the same units of time as volumetric measurements of matter or mass matter. Obviously, in the case of separated kinetic energy fields, their strength is determined by the number by the number of energy quanta in that field and the associated linear momentum that comes with that. The quantized angular momentum, the equilateral geometry, obviously determines the net charge of each field. In all cases, a negative charged object will create a negative charged geometry chem field, and vice versa. It's these arrangements of charged fields and their energy and the energy momenta that make them up that create the varying strengths of force of interaction and directions of interaction between charged particles. Again, just quickly to note that Tetryonics calls all matter tetrayonic matter because it's derived from the tetrahedral geometry, standing wave geometry of energy. Current standard physics at the moment calls these same objects fermions. They are both the same thing. They're three-dimensional standing wave mass energy geometries. Each matter geometry, or standing wave, tetrahedral standing wave of energy, has a region within it, or creates a region within it, where there is zero energy. There is no energy at all within the center of any form of matter. All the mass energy of tetrahedral matter, as in two-dimensional mass energy, is contained in the charged fascia of the tetrahedral geometry. Inside is completely devoid of anything. And in fact, it is this null space within tetrahedral geometries that creates the convergent force of gravity when the surrounding vacuum energy seeks to equalize the zero energy inside matter. This creates a strictly convergent force that will always act to the center of each matter geometry. And as tetrons form larger and larger matter geometries, mass matter geometries, the matter geometry with its null space in between increases the force, the strength of the gravity that it creates. So the larger the mass matter, the stronger the gravitational force created by it. But mass itself has no direct relationship on the strength of the gravity. Again, looking at a picture of a block of matter in motion, an elementary particle, we can see that Tetryonics clearly defines and distinguishes between the matter itself, its chem field or its kinetic energy plus magnetic moment that's generated from the matter's motion in space, and clearly shows the gravitational force created by that matter, or created by the null space of that matter, in the vacuum energy which the matter resides in. These can all be related directly back to the gravitational constant of Newton, or Einstein's constant in general relativity relating the force of gravity to the total stress energy tensor. The only difference obviously being that Einstein's formulation gave a result of 8 pi, whereas Newton's gave 4 pi. We can now start homing in on Einstein's general relativity and pulling it apart and re-describing it in terms of geometry of Tetryonics. As expressed down here, and I'll let you go into the finer details of it, is Einstein's general relativity broken down just as a gravitational constant in proportion to the stress energy created, or the curvature created by the total energy or mass energy matter that is being observed or tested in that region of space. This can all be redefined using Tetryonic geometry to just a total energy geometry that again creates a Gravitoelectromagnetic geometry, or a number of Gravitoelectromagnetic fields, all of which have a net convergent force. The gravitic field starts off as convergent only and remains that way, whereas you'll note with the blue lines here from the marking the radiated masses that the EM component is an interactive force. However, even though it's interactive, it still follows a charged geometry, triangular, and in doing so it is still net divergent. It will still radiate away from the source of matter. In the case of a planet, it'll have an electromagnetic field radiating out into space. In the case of a star, it will have its corona and it will radiate light and heat out from itself at higher densities than the planet, obviously. But in all cases, in Tetryonics, mass is a measurement of this energy per c squared or per second, whereas matter is a measurement of the same energy in a standing wave format per c to the fourth, because it is a three-dimensional standing wave geometry. Einstein's field equation here again just represented in a number of different permutations, and drawing it out is expressed this way. Again, taking the main points, stress energy is energy in all its forms is put into the stress energy tensor. Newton's gravitational constant remains, although in this case it is 8 pi when you're closer to larger gravitational objects. Matter itself, using the speed of light to form your spatial coordinate system, is c to the fourth. Einstein then plotted the curvature that various amounts of energy would create as far as the gravitational pull goes, and at a later date added the cosmological constant in order to explain the interactive forces that Tetryonics explains as electromagnetic interactions. Obviously, at this point, if you've followed from Tetryonic electrodynamics, you've realized that we've undermined in some major ways a lot of special relativity. We haven't done away with the math or the outcomes of special relativity in a mathematical sense. What we have done is we've given the electrodynamics of moving bodies physical geometry through the equilateral geometry of energy and the 4n pi or the Tetryonic geometry of matter. In doing so, we've negated the need to use special relativity in most of its formulations to explain electrodynamics, and this continues through into quantum gravitation. In fact, it will be shown that by using special relativity as his basis for developing a theory for accelerated bodies, i.e. gravitation, Einstein was unable to differentiate between mass and matter. Obviously, he put them all into his stress energy tensor. He got the end result, but in doing so, he failed to see what the real mechanics at the quantum level and at the cosmological level were for gravitation. And in return, this has just led to a number of to a growing number of errors in gravitational theory, where the mathematics goes on a path that is not supported by the underlying geometry that it describes. Tetryonics will now show you the physical geometries, what creates them, and the interactions that it creates in order to form quantum gravitation, or a theory of quantum gravitation. In return, at the end of it, you'll see that while Newton and Einstein can both still be left in their current forms, in fact Tetryonics shows the full mechanics at both scales and can resolve down to both Newtonian gravity and special relativity, but the physics of the gravitational mechanics are shown far more clearly. Space-time curvature, as it's described by Einstein, is just the curvature that matter creates within the region that you're measuring it, i.e. its gravitational pull. Tetryonics redefines matter and mass completely different to a stress energy tensor. It shows the physical geometry, i.e. mass energy has 1 or odd or even pi geometries, whereas matter itself are always 4 pi or Tetryonic geometries. In doing so, we can now define and illustrate the fact that, as noted there, any matter or standing wave energy geometry that is created in the vacuum energy of space will in fact have a null space geometry internal to itself, a lower energy density despite its mass. This energy density will create a convergent force. Well, the vacuum energy surrounding the zero energy will create a convergent force, which will always act to the center of the Tetryonic matter geometry. In doing so, it creates a force that we call gravity. In addition to this force of gravity created by its null spaces, all matter will radiate blackbody radiation or create a chem field if it moves through the vacuum energy. These chem fields and blackbody radiation fields are electromagnetic fields of varying strengths depending on their motion or their energy levels, and they are comprised of divergent and convergent energy momenta. The divergent and convergent components add up due to their equilateral geometry to be a net divergent force. However, close to bodies of matter, of large matter, the divergent forces will exceed the convergent forces will exceed the divergent forces. Adding up all the forces of matter, convergent and divergent, we come across a model of gravitation whereby we have convergent gravity and interactive charge fields, be they positive outward and negative outward, or vice versa. These charge fields are electromagnetic. Their quanta are in both directions depending on their charge, and they contribute to the gravitational field. So Newtonian gravity, strictly the gravity between two bodies, can be expressed as purely the circular geometries you see here around the two bodies of matter. They are two bodies not in motion, but they interact via their gravitational fields, whereas they calculate to a 4 pi gravitational force, whereas general relativity, including the special relativistic effects that Newton had developed in special relativity, the Lorentz contractions and so forth, also include the interactive chem fields or blackbody radiation of the bodies of matter. This increases the net gravitational force of a body, because you have not only the gravity acting between the bodies, you also have the electric field, the EM field acting between the bodies, and that's interactive depending on the charges involved. But they all act at all times and at differing strengths. This is modeled simplistically through general relativity, but never is it explained that general relativity is the result of gravitational attraction plus electromagnetic interaction. And that's the great failing when mass, matter and energy aren't distinguished. Obviously the Higgs field has been brought back into physics recently. It's simply, again, just another terminology for the ether. It is the energy field that all matter moves through, and all matter being comprised of charged fascia, which in turn are electromagnetic inductive fields. As they move through the energy field of the Higgs field or the ether, these charged geometries will resist, the energy content of the geometries will resist changes to their energy content. We term this inertial mass. Electrically, it's identical and caused by the same properties as inductive masses. The charged geometry of matter is a equilateral inductive geometry electrically, and those charged geometries form the fascia of all matter. Matter, as it moves through an energy field, will resist the motion, but in doing so, as it does accelerate through the field, it will create a secondary chem field, a kinetic EM field, which is proportional to the square of the velocity of the mass matter being moved through the field. Again, a lot of the current terminology for various things in physics has grown because of the rejection of various other older terms by through relativity. Relativity has been accepted and tested without fully understanding the energy mechanics and geometry underlying it, simply on a mathematical basis and on physical tests of that math. It's not until you understand the equilateral geometry of energy and its inductive nature and the charged geometry of matter and distinguish between the two that you realize and can differentiate to the errors that mathematics are now currently proceeding to generate by not understanding the two and differentiating between mass and matter. To that point, obviously, as I said, all mass energy, as described here and as noted, down the left-hand side we have mass. It's purely a measure of energy content per c squared. It's measured in kilograms, and as you can see, energy density per square meter. However, obviously, in the case of matter to the right, we have to measure the energy density per cubic meter, because it's a volume that matter takes up that differentiates it between mass. Additionally, all matter geometries have charged fascia comprised of mass energy. Mass is a property of matter. Matter is not a property of mass. Tetryonics explains the conservation of mass and highlights why matter is not a conserved quantity. It explains Newton's laws along with Newton's law of gravitation, and it gives us a clear understanding of the stress energy tensor and the gravitational mechanics of general relativity. Interestingly enough, at the bottom of the page you'll note that in formulating the difference between mass and matter, we come to the conclusion that mass by the square of the speed of light is the energy content, whereas in the case of matter, the energy content, or the mass energy content of matter, is to the fourth, is c to the fourth. This comes about by the spatial coordinate system used to mention it, and I go into great detail on this in the fourth book on cosmology, which I encourage you to read, or in the lecture that was done 2 lectures before this one. But there is a distinct difference between mass, energy and matter, and that distinction in both cases is the square of the speed of light. Clearing this right up, and again differentiating between mass and matter, because mass is a measure of energy per second, or per c squared, whereas matter is a measure of the energy, or the mass energy content, per c to the fourth, we discover that the relationship, as I said previously, between mass and matter is the square of the speed of light. Saying this another way, we again note here that as per Einstein's equivalence, mass is just energy per second, or energy per c squared. It's an equivalence between the two. However, because matter is made up of tetrahedral geometries of mass energy, where each fascia is the mass energy of the matter, we find that the energy content of matter is e to the c fourth, but the mass content of matter is c squared. So just so that we're clear on this, the energy content of matter is c to the fourth, the mass content of matter is c squared. Another way to write that would be that E equals matter divided by C 4, or E equals mass divided by C squared. As you become more familiar and get your head around the difference between mass, matter, and the geometries, you will come to accept this and understand that there is a distinction between mass, energy, matter. Mass and energy are equivalent. Matter and mass are not. It's a one-way relationship. You can have mass in matter, but you can't have matter in mass. C4 can be divided by C squared. C squared can't be divided by C4. Mathematically and geometrically, we now have very precise definitions of mass, energy, and matter as a complete equation and a complete geometry. Gravitons, as we mentioned in the previous lecture, by virtue of their unique arrangement of convergent energy momenta, are impossible geometries to create. They cannot be physically created, and in fact there is no equivalent between electromagnetic energy momenta and gravitational energy momenta, because convergent gravitational energy is created by the higher energy, vacuum energy, seeking to neutralize or fill the lower energy or zero energy within each tetryon. So it's always a convergent force, whereas the photons that make up EM waves of chem fields and of blackbody radiation are always divergent and have interactive forces dependent on their charges. So photons are a real entity. They have a 2 pi mass energy geometry, 0 matter geometry, and gravitons are shown not to exist. They result purely through the mathematical treatment of gravitation through Newton's formula and Einstein's formula. Although mathematically they can be expressed that way, they do not, and they can be used to model gravity. They do not physically exist. Richard Feynman coined the term Gravitoelectromagnetism and tried to explain gravity in terms of the relativistic motions or inertial motions of charged matter bodies in motion, and simply explaining the difference in forces as a difference in the inertial perspective between one or the other. In this case, the left-hand side particle has the middle particle stationary. It's the inertial viewpoint, with the charge 2 electrons above and below it travelling at a velocity v. Both velocities are equal but are in opposite directions. They in turn have their own gravitational fields, and they will create their own chem fields. Chem fields again are explained in more detail in electrodynamics and quantum mechanics. You can change your relativistic point of view to the bottom particle, in which case you would have 2 particles in motion above it. The center particle that was stationary in the left-hand view will suddenly be moving at a velocity of v to the right, and the particle above that would be moving at 2 times v in the same direction. Tetryonics changes all the math that Feynman used, and the relativistic math and Einstein's math that goes into trying to explain this mechanism, simply as illustrated. You have a gravitational force from all 3 particles that remains the same. Again, because of Tetryonic electrodynamics, we've proven that the mass matter of any particle is invariant to velocity. What changes when a particle is accelerated is the kinetic energy of its chem field. So that in the cases of the moving particles, above and below that stationary particle, which has no chem field because it is stationary, each particle has a chem field generated in the direction of its motion. They are both equal because they're both v. In this case, the particles are pushed apart because the magnetic dipoles that are created by their chem fields push the opposite moving particles apart, and that's totally in line with Ampere's law. They don't affect the middle particle, because the middle particle, being a stationary electron or lepton, is made up of negative charge particles where the dipoles are neutralized. So a north dipole will be equally repelled by the north dipoles and attracted by the south. So the magnetic field has no effect on that central particle. Changing the inertial point of view to the right hand side, we see the bottom particle has no chem field because it is now stationary. The particle above it has a chem field because it is moving off at velocity v. Again, its north pole does not affect the stationary electron because its north pole repels and the south pole attracts to the north. However, in the case of the particle above it, which is moving at twice the velocity of the middle one, its magnetic dipole is stronger, and it is the dipole that is created has a north pole that is attracted to the south of the particle moving at 1v in the same direction. Again, this completely matches Ampere's laws so far as direction, current, charge is moving in the same direction, and explains the gravitational fields and the interaction of charged particles in motion in terms of gravity and their kinetic energy and magnetic moments, all in the one diagram. Using the gravitational fields and the chem fields of particles in motion, or the blackbody radiation fields of stationary particles with higher energy content, mass energy contents, we can now combine the gravito fields along with the electro and the magnetic fields of all matter, whether it be in motion or inertially stationary with respect to another body, and we can use this to develop the full quantum theory and geometry of gravitation and how the stars and planets all move in their orbits. We can then apply the same geometry right back down to the quantum level with electrons and protons. And in fact, that's what we'll be heading on to do. At the quantum level, where we have two particles interacting, whether they're charged or not, the matter of those two particles will have a gravitational field, as illustrated here. The gravitational field will have a region of interaction. The big G, Newton's constant, will interact between these points. However, at the quantum level, the distances between the particles is much smaller than at the cosmological scale between planets, and as a result, any blackbody radiation through the elevated energies of these two particles, or their motion, as in kinetic energy fields, half of these fields pointing one way or the other, will create a region of interaction which is governed by the Coulomb force, again the diamond-shaped field as it's revealed. This is the interaction at the quantum level of two particles, both in terms of gravity and their electromagnetic interactions. The combination of convergent gravitational fields created by matter and the interactive electric fields or interactive fields created by their kinetic EM fields or their blackbody radiation all combine to give us gravitation. In Tetryonics, we tend to distinguish gravity as purely the convergent energy created by the geometry of matter, and gravitation being the net attractive force created when convergent gravity and interactive EM fields combine. Can be represented, Newton represented it to the picture to to the left as the inverse square of the force between the distance. Tetryonics represented as in the middle. However, this can be viewed as a single particle field as illustrated at the right, showing the curvature or the energy density gradient. As you move closer and closer, obviously the electric and the magnetic fields add to the gravitational field. The gravitational field works from higher at a distance to lower as it tries to equalize the null space, whereas in the case of chem fields and blackbody radiation, it starts off higher, as in more quanta here, and drops as the inverse square. Again, the electric interaction exactly overlays the force that's created by the energy density as it seeks to equalize the null space. So on a large scale, with great distances between two blocks of matter, or two bodies of matter, gravity is the ruling force. As you get closer to this quantum level, you'll find that the electromagnetic force of blackbody radiation, or motion itself, its kinetic energy, dominates the interactions. But they're present on all scales. They are in fact three different forces: electric, magnetic, and gravitational, all combining into a single convergent force that's been modelled mathematically for centuries now. Breaking them up, we can see that again all bodies of matter create a gravitational field from the vacuum energy seeking to equalize the null spaces within all the Tetryonic geometries that form their matter. These fields can obviously be modelled from the center of the zero field of matter out to the other mass matter that it's interacting with, or superpositioning both fields with, and that field is a diamond shape because it's an inverse square law. Again, its constant is simply g. We can also model the gravitational acceleration of a body increasing as it approaches the center of the mass, but in all cases the geometry shows us that the forces cease at the center of the body of mass matter. Diamond shapes for inverse square geometries. Same diamond shapes apply to the electric field of blackbody radiation and kinetic energy fields of motion, or chem fields. You'll note that this time I've illustrated it purely from the electric field perspective, so there is no gravitational field resulting from the convergent vacuum energy surrounding this matter. It's purely the electric field geometry we're interested in this case, and again the strength of that field is determined by the energy momenta in the field. In the case of chem fields, it's proportional to the square of the velocity of the particle. In the case of blackbody radiation, it's proportional to the square of the energy levels that the particle has. So in this case, 1 squared, 2 squared, 3 squared, 4 squared, whatever the geometry of the particle and its mass energy levels will determine the strength of the energy momenta in its electric fields in its blackbody radiation. Again, it's an inverse square law, just like gravity. Gravity can be modelled using the same geometry. However, it does not have the same geometry. Its force just follows that because it's an inverse square. In the case of electric fields, obviously, we have a net divergent force being created in the electric field with its energy momenta, because it's an equilateral geometry with the magnetic poles as well. But in doing so, dependent on whether it's a positive or negative charge or a combination of both, the energy momenta will determine the interaction with other particles, and in particular other charged particles that come into that field. If a negative charge particle were to enter this side of the electrostatic particle, it would be attracted. If it were to enter this side of an electrostatic particle, it would be repelled. If this was a positive electrostatic particle, these would both be positive charge fields, and in that case the negative momenta this side would be reversed, so a negative charge particle would be attracted no matter which side it approached from. But because it's a neutral, it has a differing effect. This interaction is an inverse square interaction, and it's additional to the inverse square force that vacuum energy creates, that we call gravity. In addition to both of those inverse square forces, we also have an inverse cube force on all matter, created by its chem or blackbody radiation. These magnetic dipoles diminish as the cube of their distance from them as a dipole, or as a magnetic pole. It's an inverse squared relationship, but that's explained in the Bose-Savart law in electrodynamics to much greater detail, and in fact it's modelled out there as well. But as a dipole, all dipoles diminish as a inverse cube law from their point of source. So on top of the radial convergent radial force of gravity and the inverse squared interactive force of electric fields, we also have the interactive cubed force of magnetic fields. Again, all acting at the same time from the same mass matter point or mass matter object. All these forces then combine, and you can view them best in this model, where we have the radial vacuum energy seeking to equalize null fields in the center of matter. In this case, we've taken the picture of the matter out just to highlight the fields. As a particle moves closer and closer to another matter object or another particle, it stops being, it continues to be influenced by the gravitational field. However, it encounters a stronger electromagnetic field depending on its direction of interaction. In most cases, the diamond geometry of the electric field creates a greater radial distance than the diamond geometry of a magnetic pole. It's again, the magnetic pole is an inverse square law, but the dipole is an inverse cube law. By itself, a diamond shape is the same as that electric field, but as a double diamond, it's got a different geometry, and you'll see that it doesn't radiate out as far as a magnetic field as the electric field does. So the first interaction from a distance will be a gravitational attraction. You will then have a gravitational attraction followed by a interactive electric force, and really close into an object you will begin to get an interaction by the north and south poles of the magnetic dipole. Now the north and south poles, because all matter has a north and south dipole even down to its most basic energy geometry, does no work. It doesn't pull it in one direction or the other or accelerate it like the electric field does. What the magnetic dipole will do is that it will perturb it. It will move it in an odd geometry. It won't accelerate. It'll just change the orbit slightly. Leverrier explained that a lot better way before Einstein as a mathematical modeling of magnetic fields. But that perturbation, even though it was used by Einstein in some of his discussions, was never taken up, and Einstein failed to realize that his stress energy tensor, which is all the mass, matter and energy in this c to the fourth geometry or spherical spatial coordinate system, is made up of vacuum energy, electric fields, magnetic fields, and the standing wave EM geometry, mass energy of matter itself. Tetryonics now completely reorganizes Einstein's stress energy tensor on a mathematical and a geometric basis to reveal the true interactions of gravitation as being the result of three differing interactions of mass and matter. within any region of space-time or spatial geometry. Again, just stressing that matter creates gravity, and it creates it because it has a null space inside each tetrayonic geometry, and in turn the vacuum energy external to the matter geometry seeks to equalize that zero energy density, and it does so by pushing in on that geometry all the time in a convergent manner. In addition to gravity pushing in, obviously the blackbody radiation or the chem fields create divergent interactive fields around matter as well. So inside matter, as illustrated there is no energy. Outside there is vacuum energy pushing in, green arrows pushing inwards, gravitation, and there is also chem fields radiating energy out, creating an interactive charge field, some of which is inverse cubed, some of which is inverse squared interactions. Newtonian fields model the attractive forces between gravity on a simplistic basis. This is, of course, so it's describing the convergent force that each body of mass matter creates. Einstein says that it's a result of this curvature of the vacuum energy that matter creates, because it's got nothing inside of it. So when it's created, this is then a curvature that seeks to be equalized, and this curvature is followed by particles in motions trying to go in the straightest line that they can, but in doing so they follow a curved trajectory. Purely gravitational fields, where if you were to be able to create them and have no kinetic energy or stationary bodies and no blackbody radiation, so absolute zero, no motion, no energy radiated whatsoever, would follow this geometry. They would simply be vacuum energy seeking to equalize at the center of the mass matters. In both cases, the convergent fields of both mass matter bodies will be proportional to the amount of mass matter in both geometries, and the force between those bodies could be described with a diamond or an inverse square geometry. And again, the gravitational constant can be calculated through the ratio of the force, or the force between the ratio of the two bodies, taking into account the ratio of the mass matter in both bodies. So the gravitational acceleration on a body is strictly a result of the vacuum energy trying to equalize the mass energy of that body, whereas the gravitational force between the two bodies is proportional to the fields created by both those bodies and is proportional to their constituent mass matter. The gravitational tidal forces often discussed. Again, we can draw that the difference between acceleration and gravitational forces as an equilateral geometry. In this case, it almost is exactly equal, but because of the equilateral geometry, there is slightly more acceleration than gravitational, which isn't the case in real life. The vacuum energies always act to the center of the mass matter that creates that 0 point energy region. The black body or the kinetic energy fields always radiate outwards from that body, and between the two bodies there's always an attractive force between the center of the two objects, as described in Newton's formulation between the two, always to the dead center. All these forces of gravity, electromagnetism, and in fact mass, matter and energy itself can all be described and modeled using the unified field equation here. Simply put, it's just a spatial measurement of energy. The energy can be either measured as Planck quanta, mass, angular momentum, quanta as in Compton's frequency, velocity, quanta squared, or it can be measured as mass velocity as a scalar measurement. By measuring it in a spatial geometry of c squared, we obtain electric and magnetic fields, as opposed, if there was no time measurement, you wouldn't be able to measure the electric and the magnetic, so you would just have a pure energy content. And again, if that mass and energy were measured in were to be formed in a tetrahedral geometry, a T pi or 4n pi geometry, you would then create matter. Again, obviously matter can have the properties of electromagnetic mass energy, but because of the tetrahedral nature, you can't have matter being a property of mass. This formula will be applied very shortly to quantum gravitation to give you some specific examples. Here's the first one. In this case, we're just looking at the Coulombic force between two charged particles, in this case a charged deuterium or deuteron and an electron. Doesn't matter what their energy levels are, they're both in motion, they both have chem fields. Even if they weren't in motion, they would have blackbody radiation, and that would be in the shape of the same chem fields, although much weaker. You can see they have a gravitational field, but obviously gravity being 1 to the 20 times weaker than the electric field, or electromagnetism, plays no real role. It still exists, and it's still present at the quantum level, but it is a force that is not created and does not have the same geometry as energy momenta. It is created by the lack of energy momenta when tetrahedral geometries are formed in vacuum energy. So it's a completely different mechanism to the Coulombic fields of force. Back to the Coulombic fields of force, we can rewrite the geometry expressed here as simply a measure of the mass of the protons and electrons per c to the fourth, because they're matter, or the energy content in this case. We can again measure the energy content per c squared, or the mass energy, for the chem field that's coming out of this proton. It'll be a positive field, obviously, towards the electron. And likewise, the electron has a matter geometry of 12 pi, so it's 12 pi over c to the fourth, with a chem field of its own, or containing mass energy or an energy momenta of a negative field geometry that interact. Over the top, they form a energy squared field, so obviously it's squared, it's proportional to the distance between the two, but in squaring it, or superpositioning the two c squared fields for mass energy become a c to the fourth. So all that rationalizes out, and you just have the energy of this particle creating a proportional energy field in its chem field, and this matter creating a proportional energy field in its chem field. The two overlay and interact in exactly the same inverse square geometry as what gravity does in the same region, however 10 to the 20 times stronger. So gravity can be more or less ignored, and in this case what determines the interaction between the two particles is the energy momenta of their chem fields that they're creating. If they were more or less stationary, it would be their blackbody or their charged fields, because they're both charged objects. The charged fields would again interact in exactly the same way, positive and negative. The energy momenta, if you look closely, you'll see that the negative energy momenta will accelerate the negative charges towards the positive. Additionally, as per Newton's laws, there will be an acceleration of positive charges to the negative electron. However, the energy momenta of the chem field of the electron is much smaller than the same geometry field of the proton, So proportionally, in proportion to the mass, the force will be proportional, and the electron will be more or less pulled to the deuteron nuclei to form deuterium. That's an explanation of the mathematics and the geometry of Coulombic field interaction along with gravity at the quantum scale. At the high end, at the cosmological scale between planets, exactly the same process between matter, the energy field that it creates, and in proportion to the size of the mass matter that creates the field, we end up with a gravitational field. The difference in this case is that the amount of matter creates a proportional amount of null space in the vacuum energy, which increases the gravitational field, or the convergent vacuum energy, as it seeks to equalize that field. Of course it can't, because matter is a tetrahedral geometry, but the amount of pushing to equalize a greater zero energy is obviously greater than that of the moon's smaller amount of zero energies. Again, you can model it with the Tetryonic matter geometry per c to the fourth. You can, in both cases, the moon and the earth, their differences in mass matter create a different amount of gravity in both cases. However, by sheer coincidence, the force between them is an inverse square force, and you can model that again, as we did with the Coulombic interaction, as a chem field. In this case, the chem field doesn't physically exist as an electric magnetic field, because it's gravity we're talking about. However, you can calculate the energy content, or the mass content, the energy content, of the Earth, and draw it as a triangular field pointing to the moon. And likewise, calculate the energy content of the moon and draw it as a triangular field pointing to the Earth. They will overlap, and they're identical geometries. They point to the center in both cases of each matter object. They just have different strengths because the energy content is different between the two, and you can use the same interaction as you did with Coulombic fields to calculate the gravitational interaction. That's exactly what Newton did. He had no idea of the mechanism. In fact, there is no mechanism as he described it. Is as Einstein described the mechanism. It's a curvature of the energy gradient of vacuum energy. However, the math works, and that formulation is what gives you the geometry to give you Newton's typical formulation for gravitational fields. The circular vacuum energy gradients is what Einstein describes in General Relativity. However, he fails to account for the electric and the magnetic fields. Well, he accounts for them, to be honest. He just doesn't recognize them as being electric and magnetic fields. He calls them all gravitational fields, and that's not the case. Again, just a comparison between Newton's gravitational forces and Coulomb's law of attraction using the unified field equation to describe both. We can describe them in this case as mass velocity as opposed to energy quanta, and we can just model it on the motion of the objects towards each other. You could just as equally apply it to the energy content as we've done down the bottom. It's one or the other, as we've discussed in depth in quantum mechanics and electrodynamics. The unified field equation of mass, quantized angular momentum, quanta squared, can be reversed or combined to give us Planck's quanta squared or mass velocity squared. In either way, it's just energy we're looking at. We know the geometry of the energy in this case, so we can use that to show that Newton and Coulomb's constants are in fact the same sort of thing. Newton's doesn't exist in reality in the form that it takes in Coulomb's constant. However, they both have inverse squared geometries, and as such, one can be expressed as a weaker version of the other. Tetryonic gravitation, again, same thing. We're just saying that Newton's formulation of gravity can be described as a inverse squared geometry using the unified field equation for energy and matter geometries. In the case of energy, the same fields produce, Coulombic fields produce an inverse squared, the same as geometry, through their E squared superposition of kinetic energy fields. It's the vacuum, it's the vacuum energy fields that are displaced by matter geometries with their null space internals that creates convergent gravity, whereas their energy fields and or their motion create interactive chem fields around the body that act in addition to convergent gravitation. Newton described it as a inverse force without explanation. Einstein tried to explain it, but lumped it all together as gravitation without explaining the difference between mass and matter, interactive forces, and convergent gravitation. We can finally apply the Tetryonic unified field equation to the geometry of gravitational fields as an inverse square law, and to electric fields as again an inverse square law that's superpositioned, and magnetic inverse cubed fields. In doing that, we can distinguish between where the Coulombic charge interaction takes place versus the convergent attractive only force of gravitation, or energy density, that creates the fictitious or fallacious force of gravity. We can then calculate the geometries, and we'll actually see that even including the alpha constant as the which is, again, for those that are unaware, the alpha constant is simply the equilateral geometry of energy, or the quantized angular momentum of energy, which creates charge and so forth. It gives us the strength of the number of energy momenta per charge field for interaction, and we can use that same modeling for the energy content of matter and the forces of gravitation between those two blocks of matter, using alpha and E squared fields, along with our understanding now of mass, energy, matter, and gravitational versus electric and magnetic fields. We can apply it, and we find something interesting. We find that doing it all, we have a total field of 64 pi gravitational energies per c to the fourth. The square root of that, which is our force, obviously, of the total field, gives us 8 pi. And that 8 pi is exactly what Einstein calculated for in general relativity. We can then go further, because obviously we want to see it reduced down to Newton's 4 pi, and we do that by removing the 4 pi of an EM field interaction, so that it's purely gravitational, as we've discussed. In a purely gravitational field with no blackbody radiation and no interactive chem fields from the motion of the matter, you would remove half of that and you would end up with 4 pi. So this confirms that Newtonian gravity, mathematically correct, modeling something that doesn't exist, i.e. a force, is 4 pi so far as relativity and Tetryonics geometry goes. General relativity, close to massive bodies within their fields, the bodies are obviously in motion. They obviously have, in general relativity, all the energy of motion as well as the gravitational energy of their matter is lumped into the same stress energy tensor. So therefore it all adds together. You have gravitational energy, you have the interactive chem fields or black body radiation of the body, in addition to the gravitational field. Einstein lumped them all together because special relativity didn't distinguish, and it was used as the basis for general relativity, and that gave him a formula of 8 pi. In reality, I suspect he got the 8 pi by knowing what he had to, what number had to be obtained in order to match Mercury's perihelion, and then just calculated 8 pi to match Mercury's perihelion and left it at that. It was sort of like knowing It's easy to find the answer when you know what you're looking for. In this case, Tetryonics gives us the geometry and gives us the reasoning behind the difference in Newton's gravity and general relativity. The key point here is, now that we have a difference between purely gravitational fields and Newton's way of modelling the gravitational force between two different blocks of matter, we know that they follow an inverse square law. We know that Newton's field for gravity, ignoring all other contributions of mass energy, gives us 8 pi g for the total energy content, whereas Einstein's gives us 8 pi for when we're closer to account for the perihelion of Mercury and other things. We can now distinguish between the mass energy matters that are lumped together in Einstein's stress energy tensor and further explain quantum gravity as opposed to Newton's universal gravity. And in doing so, we can produce a model like this, where we can show the geometric model of matter. We can show the gravitational force that's created by the vacuum energy that matter displaces. We can show that the mass of matter is the result of energy in its charged geometries, again resulting from the various energy levels as the matter is created for various forms of matter. And we can show that blackbody radiation, which would be represented as 2 arrows in this case, or kinetic radiation of energy of motion, can all be represented in one diagram. In this case, the universal field equation gives us the charge, which creates the geometry of mass energy matter. It gives us the geometry of matter along with its energy or its mass content. It can give us the geometry and the interactive forces or Coulombic forces of matter in motion or electrostatic particles as they interact. And we can bundle all of that together into a term called relativistic energy or total energy, which is just simply how many geometries of energy are there for any system. We can expand this system with 2 bodies. We can change the energy geometry or the mass. We can put in the same particle and lower its mass content or raise its mass content. In raising it, we would have an additional field if it was electrostatic. If it was moving, this kinetic energy field would increase and its interaction would obviously increase. We can do all that through kinetic gem fields. So we have Tetryonic mass energy matter creating Tetryonic chem fields of motion in electrodynamics, all together creating Tetryonic gem fields, which gives us the geometry and the physics of quantum gravitation. Finally, because it's matter, you can abbreviate matter down from its formula, once you grow familiar with it all, to just being T pi man, which is just tetradic geometries, mass, angular momentum by the energy level of the matter. And that will give you all this as well. As I mentioned, you can do a 2-body interaction between particles, and this highlights, a 2-body interaction highlights the power of tetradic geometry and quantum gravitation, in that when you bring them together, you can see at a distance just purely gravitational fields. A little bit hard to see on this page, but if you were to move out to, say, the bottom away from the pages where it's just purely gravitational fields, you would have a 4 pi gravitational energy field interacting in this region here, top and bottom, as the vacuum energies interact. Closer in, you will suddenly come to a region of interaction. Now this region might be magnetic first, or it might be purely that you move into the electric first. In this case, we've got two particles that are almost touching each other. They would have started off apart and moved in. But the interesting part is that whether it's electric or magnetic that you approach to, it'll be a 4 pi interaction, which will increase from 4 pi gravitational to an additional 2 pi in the case of magnetic. So you'll have a 6 pi interaction, increasing to another interaction here of another 2 pi if it was separated, which would be 8 pi. So 4 pi Newtonian at a distance becomes 6 pi as you approach closer. Now that may be electric or magnetic. Obviously most times the electric is the first to be encountered as particles move together. So you would come in from, say, this direction, you would have a 6 pi gravitational constant. But when these fields finally interact and apply over the top, they're a 4 pi by themselves. So you would have the 4 pi of gravitational and the 4 pi electric field, which makes 8 pi of general relativity. So this particle, if you were able to move it backwards and forwards, you would see would wax between 4 pi Newtonian gravity to 8 pi general relativity, and all scales in between based on the geometry of the chem fields as they interact, to create a Tetryonic model of quantum gravitation, where we have gravity, convergent gravity, and interactive electric and magnetic fields. So in a nutshell, Tetryonic unified theory not only gives us the power to make worlds, it gives us and explains the power behind moving worlds. We can now explain the instantaneous transfer of energy between the sun and the planets in the form of chem fields of longitudinal waves. We can explain gravitation as something that's created by matter, but it is a completely different force to that of electromagnetic fields. We can explain the energy of motion, the magnetic moments of motion, of charged particles, etc., as explained by special relativity. And in doing so, we replace special relativity and general relativity with a unified theory, a geometric one, of equilateral energy, explaining everything from the basic Planck quanta of energy momenta, right up to building matter on any scale and facilitating gravitational interactions at both the quantum and cosmological scales in a way that matches existing Newtonian and general relativity theories, but at the same time enhances and produces testable hypotheses that we can use to advance science and technology in many new ways. We'll finish this one here, as it's the final one for explaining quantum gravitation. The final lecture in this series will be an explanation of gravitational effects and stellar processes in planets and stars. Thanks for tuning in.